Welcome back, Math 136 students. Today we're going to talk about Chapter 2, Section 4, which is circles. The definition of a circle is the set of points, all points in the xy coordinate plane that are a fixed distance r. Fixed distance meaning that it's a constant distance, does not change, and this distance is a special distance called a radius from a fixed point h, k called the center. So in other words, if you have some fixed point h, k here, all the points that are a distance r, let's say right there, all the points, and this is not a very good diagram, but you get the idea, all the points, and there's infinitely many, form a circle. Now, it's a terrible looking circle, but it gives you an illustration of what I'm talking about here. So those points all form a circle. Now, this definition references the distance, a distance r. So what I would like to do is reference the distance formula, which we just discussed recently in class. The distance formula was d is equal to the distance between 2 points, the square root of the quantity x2 minus x1 squared plus y2 minus y1 quantity squared. All right, well, we refer to a distance and we define it as r, so I'm going to replace the variable d with r. And we also define one of the points being h, k, which would be the center of the circle. So I'm going to rewrite this as x minus h quantity squared plus y minus k quantity squared. And that is your, one of the variations of a standard form of a circle. Now what we typically do is square both sides. And by squaring both sides, it cancels out the square root and squared on the right side. So your standard form of a circle is r squared is equal to x minus h quantity squared plus y minus k quantity squared. And again, this is standard form of a circle. Another quick definition would be for the unit circle. The unit circle is a special type of circle, and as such, the equation looks a little different. So if a circle has radius of 1 unit and its center is on the origin or at the origin, then it is considered a unit circle, and the equation, all right, just look back to the equation we had earlier. We had, remember, r squared is equal to x minus h quantity squared plus y minus k quantity squared. Well, we know the radius now is 1, and 1 squared is 1. And we know that h is 0 and k is 0. And if you simplify this, you get x squared plus y squared. So the equation for a unit circle is x squared plus y squared equals 1, or 1 equals x squared plus y squared. For our first problem, we're going to write the standard form of the equation of the circle given certain information. So the first piece of information we're given are 2 points on the circle. Now notice here the 2 things that we want for our equation are going to be the radius and the center, and we're not given either. So what we have to do here is find the radius and the center given these 2 pieces of information. First thing I would highly recommend you doing, which is why I included the coordinate plane off to the right here, is to plot these 2 points. So what we have here is 1, 2 and 4, 2. And the reason that I think it's relevant to plot is because the center will be in between these 2 points, which, by the way, that's a line segment, and the point that's in between 2 points on the line segment is considered a midpoint. So what we're trying to find here is the midpoint. All right, remember the midpoint is the sum of the x values divided by 2 and the sum of the y values divided by 2. And when we get that, we get 5 over 2 and 4 over 2, which is equal to, and I'm going to convert this to decimal form, 2.5, comma, 2. All right, the next thing we need, and again, that was the center we just found. The next thing we need is the radius. Well, look at this. We notice here that the y values happen to be the same for all of our points. So the y values will not help us find that radius or that distance from the center to those outer 2 points. What we do want to look at is the x values. All right. So 2.5 happens to be the middle point, and the distance from the center to either of these 2 points will be our radius. So in other words, our radius will be 4 minus 2.5, which is equal to 1.5. Likewise, if you took 2.5 minus 1, you would get 1.5 as well. We're going to go ahead and substitute all this information into our standard form of a circle. So it's going to be the radius, which is 1.5 squared is equal to x minus 2.5 squared plus y minus 2 squared. The last thing we're going to do is to square the radius, so that will then result with a 2.25 is equal to x minus 2.5 squared plus y minus 2 squared. And that's your final answer. That is the standard form of the circle given this information. Problem number 2 is asking us to again write the standard form of this equation, and we're given now an r or radius and a center h comma k, which happens to be 4 comma negative 3. What I'm going to do here is ask that you, number 1, write the equation and also graph this. So first let's start with the equation. So we know it starts with an r squared, so 5 squared is equal to x minus 4 quantity squared plus y minus a negative 3 quantity squared. Now 5 squared is 25 is equal to x minus 4 squared plus, and notice the double negative, which does in fact change to a positive, so y plus 3 squared. Alright, so we've got two things here. We've got a center and we have a radius, so I would highly recommend when graphing these that you first plot the center to the right 4 down 3 units. So that'll be right about here. And then from that center you count up, down, left, and right 5 units. So it should be to the right 5 units, which would be 9, down 5 units, which would be 8 right here, up 5 units, which will be positive 2, and then to the left 5 units, which will be negative 1. And I will do my best to draw a nice looking circle, but from here you connect these 2 or 4 outer points to form a nice circle. And that's the graph of your circle. Now, I want you to go back to the equation, and I do want to make a special note that if you were given an equation and asked to find the center and the radius, you would just simply square root the 25 to find the 5, which would be your radius. You would then want to extract the center from these two values. Notice here, though, that that's a negative 4, which actually turns into a positive 4 when you're putting it into this ordered pair, and this is a positive 3, which would turn into a negative 3 when putting it into the ordered pair. So you got to think in terms of your opposites. There's another form of a circle, and it's called the general form of a circle. The general form of a circle happens to be x squared plus y squared plus ax plus by plus c is equal to 0. Now, we need to be able to convert from standard form to general form and also general form to standard form. The following problem we'll practice from standard form to general form, and in class we'll practice from general form to standard form. Last problem, we are given now information that I'm asking you to write into standard form, and then from standard form I'm asking you to convert to general form. First things first, let's convert it to standard form, which we've practiced a couple times. I'm even going to change the order just a little bit. I'm going to start with the ordered pair x minus h, which in this case is 0, quantity squared, plus y minus a negative 1/2 quantity squared is equal to 1/2 squared. Alright, from here I'm going to simplify as much as I can. X minus 0 happens to be x squared plus y minus a negative happens to be y plus 1/2 squared is equal to, we have in this case 1/4. 1/2 squared is 1/4. Now this is standard form. I would like you to now convert this to general form. Off to the side I'll show you some additional steps to help you. So general form means that you're simply going to continue to simplify this. Now x squared, nothing we can do with that. 1/4, again, nothing we can do with that. Y plus 1/2 quantity squared, yeah, we can do something with that. So off to the side, I'm going to go ahead and rewrite that as y plus 1/2 times y plus 1/2, which then will simplify, and I'll substitute it back in. So we go FOIL, or distributive property, y times y is y squared. Then we have plus 1/2 y plus 1/2 y. And finally, last, we would have plus 1/4. All right, simplify that a little bit more. We have y squared plus y plus 1/4. Okay, let's substitute that back in now. We have x squared plus y squared plus y plus 1/4 is equal to 1/4. All right, last but not least, what we should do is get this equal to 0, because if you recall, standard form was equal to 0. So I'm going to subtract 1/4 to both sides. It cancels out the 1/4 on both sides, in fact, and so your answer, final answer in general form, is x squared plus y squared plus y is equal to 0. All right. One thing I would like you to do for class is to review how to complete the squares, which will help us in the process for converting from general form to standard form. All right, good luck. Take your notes, and I'll see you in class.
You're awesome.